Hello. So let's talk about the session "The Odds of Finding Love." I'm going to present the second part of this activity. So you were asked to draw a tree diagram to represent the situation. So the idea was that Patrick Moberg met the famous girl. He fell in love in the subway. So we start with a tree diagram, starting with a double branch. The first one leads to the event A. His date is attracted to him, and the second one to the complementary event, not A. So in this exercise, we start with the prior probability. This is a guess, baseline, but nothing really serious about the numbers in this exercise. So we start with 10% or 0.1. Here we'll have 0.9 because the two of them add to 1. And then if she is attracted to him, we guess that we estimate that their initial conversation is going well with a probability of 0.8. So another double branch here, 0.8 there, 0.2 here, because you have these, when you add them, you have to get 1. Now, if she's not attracted to him, the probability of having a nice conversation will be less. It will be 0.3, so 0.7 here. We complete this tree diagram with the different outcomes of this situation. So for this branch, it will be A and E, A and not E, etc. And then we can find out the probabilities of these outcomes. So we multiply the probabilities we find along the branch here. 0.1 times 0.8, we find out 0.08. Same reasoning for the other branches. And we make sure it's okay by adding them up, and we find 1, because these are the only outcomes possible. So now you have to find a conditional probability, the probability of A given E. Remind the formula you learned in math class. The probability is equal to the probability of A and E divided by the probability of E. So we already have the probability of A and E. It was 0.08, and we had to divide it by the probability of E. We didn't compute it yet, so you have to find it out. For the probability of E, you have 2 outcomes leading to this, and you add their probabilities. And you find a probability of 0.35. So you divide them and you find approximately 0.23. So you have 23% of chance that she is attracted to him, given the fact that their conversation is going well. It's really greater than our prior probability. You double it. So now later on in the date, the conversation is going well, so he will try to kiss her. We'll find out the probability that they will kiss. So new tree diagram here. And so we replace our prior probability by the one we just compute, because we know that the probability is going well. So now the probability she's attracted to him is greater, it's 0.23. We find the probability of node A. Now the probability they kiss, given the fact she's attracted to him, is 0.7. The probability they kiss, given the fact she is not attracted to him, will be only of 0.1. We have here the different outcomes. We can find out the probabilities of these outcomes by the same reasoning as with the first tree diagram. And now we'll find the probability of A given K. So we need, first of it, we need the probability of K. So we have two different outcomes leading to K. So we add their probabilities and we'll find 0.238. Now, to have the conditional probability, we divide the probability of A and K by the probability of K, and we find out 0.68. So that means that 68%. So now we have a probability, the odds are of 68% that she liked him, given the fact that they kiss. So obviously this was strange, and that was not really how do you say that, not really serious, but that was fun.